Hi everyone, this is the last lesson for this Friday. So far today we've been talking about events and sample spaces and how those are related to probabilities. And we are continuing that in this lesson with permutations. So remember, a permutation is an arrangement of things where the order matters. So here's how we calculate a probability with permutations. The probability P of a certain type of permutation, we read that's a Greek letter called sigma. The probability of this happening is given by the total number of ways that sigma can occur divided by the total number of permutations. This looks a little bit scary at first, perhaps, but hopefully once we do these two examples, it will clear things up. So in our first example, suppose a radio show is holding a contest where the first, 25th, and 50th person who calls into the show wins tickets to a concert. Assume 50 people decide to call into the show. If Lisa and her friends Renaud and Olivia call into the show, what are the chances that Lisa is the first caller, Renaud is the 25th caller, and Olivia is the 50th caller? So we have 50 people that are calling here, but I need 3 people, Lisa, Renaud, and Olivia, to be in specific places. So let's maybe draw this situation out. So I have 50 slots, lots of slots. And so I have 50 of them, right? And I want Lisa to be the first caller. I want Renaud to be the 25th caller. And I want Olivia to be the 50th caller. So Lisa, Renaud, and Olivia have to be in these slots. So these guys are all fixed. So how many different ways are there for this situation where Lisa is first, Renaud is 25th, and Olivia is 50th to occur? Well, if 50 people call, I already have 3 of them accounted for, right? So in the second slot, there are how many different possibilities? There are 47 different people who could call in to the second slot. Why 47? Well, we have 50 people total, and I already have 1, 2, 3 accounted for. So there are 47 people who could call in second, 46 people who call in third, 45, and then we go all the way down to Olivia, right? So we have 47 times 46 times 45, all the way down. There's only one person once we get down to right before Olivia, right? That's the last person that calls before Olivia. So again, this 47 comes from the fact that I have 50 people and 3 of them are already fixed. So I only have 47 people for the second slot. So how many different ways can my event that I care about occur? So the number of ways that Lisa can be first, Renaud can be 25th, and Olivia can be 50th can occur. Well, this is the multiplication principle, right? Since I have 47 possibilities for the second, 46, 45, all the way down to 1, this is 47 factorial ways. And then what about the total number of permutations? Well, again, this is the multiplication principle. If I ignore the situation that I want to occur, and I just think about how many different ways are there for 50 people to call into a show, that is 50 factorial, right? There are 50 possibilities for the first person, 49 possibilities for the second person, and so on and so forth, all the way until the last person, where there's only one possibility. So then according to my formula here, the probability is 47 factorial over 50 factorial. So if I were to write this out, I'd get 47 times 46 all the way down times 1, and then over 50 times 48 times, what, I forgot 49, didn't I? 49 times 48 times 47 times all the way down to 1. So some stuff cancels, right? I can cancel all of this stuff with all of this stuff. And I'll be left with 1 over 50 times 49 times 48. And if I were to calculate this, it would be 0.000000085. So extremely unlikely that this is the case, but it's possible. So yes. All right. So that is kind of one of these examples, how to calculate a probability with a permutation. We saw which ones were fixed, and then we calculated the total number of possibilities that the situation that we want can occur, and we divided it by the total number of permutations. Let's do another example. In a horse race with 7 horses, you make a bet by predicting the ranking of all 7 horses. If you place your bet at random, what is the probability that you will get the first, second, and third horse correct, and in the correct order? So I have 7 horses. 1, 2, 3, 4, 5, 6, 7. And let's see what the number of ways that a sigma can occur is. So I guess the first one correct, the second one correct, and the third one correct. So these are all fixed. Okay, so I have 3 horses already accounted for. How many different possibilities are there for these last 4? Well, there are 4 possibilities for this one, since I have 7 and 3 of them are already accounted for. I have 3 possibilities here, 2 possibilities here, and 1 possibility here. So the number of ways that my situation that I want to occur is 4 factorial, right? 4, 3, 2, 1. So number of ways that sigma occurs is 4 factorial. And then if I ignore the fact that I get the first 3 right, how many different possibilities are there for me to bet on 7 horses at random? Well, there's 7 possibilities for the first slot, 6 possibilities for the second slot, so on and so forth, all the way down to 1. So the total number of possibilities is 7 factorial. Again, that's the multiplication principle. So then our probability is 4 factorial over 7 factorial. Well, that's 4 times 3 times 2 times 1 over 7 times 6, 5, 4, 3, 2, 1. So canceling out, this is 1 over 7 times 6 times 5, which is 0.00476. So that is the probability that by betting randomly on 7 horses, you'll get the first, second, and third correct. All right, that is it for today. Hopefully you come to the Zoom meeting if you have any questions about these 3 lessons. Have a great weekend, and I'll see you later.